Sign of a quotient of two binomials of the form ax plus b over cx plus d. Property: given the quotient of two binomials ax plus b over cx plus d. To study the sign of this quotient, we have two steps. First step, solve ax plus b equal to 0 and cx plus d different from 0. Ax plus b equal to 0, so x equal minus b over a, and cx plus d different from 0, then x different from minus d over c. Second step, set up the table of signs of ax plus b and cx plus d. The table of signs x minus infinity plus infinity. As we said before, we assume that minus b over a is less than minus d over c. Ax plus b, cx plus d, and the quotient. Ax plus b, the root is minus b over a. Before the root, opposite sign of a, and after the root, the same sign as a. Cx plus d, the root is minus d over c. Before the root, the opposite sign of c, and after the root, the same sign as c. Here we have the multiplications of signs, but first we need to shade this part since we say that x different from minus d over c, so this value minus d over c is eliminated from the domain. Here we have a 0, 0 multiplied by cx plus d is equal to 0. And now the multiplication of the signs give the sign of the quotient. Example. Study the sign of q equal x plus 1 over x minus 2. First step, find x plus 1 equal to 0, so x equal minus 1. X minus 2 different from 0, so x is different from 2. Now we set up the table of signs as follows: x minus infinity plus infinity, minus 1 is less than 2, x plus 1, x minus 2, and at last the quotient q. X plus 1 is 0 at minus 1, so put a 0 at this column. Before the root, opposite sign of a, so we have a negative sign. A is equal to 1, the coefficient of x. After the root, same sign as a, so we have a positive signs. X minus 2 is 0 at 2, so here we have a 0. Before the root, opposite sign of a is equal to 1, which is positive, so we have negative signs. After the root, we have the same sign as a, so we have a positive sign. Then we multiply the signs. Minus times minus is plus. 0 multiplied by x minus 2 is 0. Plus multiplied by minus is minus. Here we didn't make the multiplication since we say that x is different from 2, so we shade this part, and at last plus times plus is plus. So the sign of q is positive if x belongs to minus infinity minus 1 union 2 plus infinity. It's negative between minus 1 and 2, and it's equal to 0 at x equal minus 1, and it's not defined at x equal 2. Application. Study the sign of each of the following products. Solution. First, q equal x minus 2 over 1 minus x. X minus 2 is equal to 0, so x equal to 2. 1 minus x different from 0, so x is different from 1. Plot the table. X minus infinity plus infinity. 1 is less than 2. X minus 2, 1 minus x, and the quotient q. X minus 2 is 0 at 2. Before the root, opposite sign of a is equal to 1 is positive, so we have negative signs. After the root, same sign as a is positive, so we have a positive sign. 1 minus x is 0 at 1, so put a 0 at this column. Before the root, we have opposite sign of a is minus 1, which is the coefficient of x, so we have a positive sign, and after the root, the same sign as a, so we have negative signs. Now we perform the multiplication. Minus times plus is minus. 1 is not in the domain, x is different from 1, so we shade this section. Minus times minus is plus. 0 multiplied by 1 minus x is 0, and the plus multiplied by minus is minus. 2, x minus 3 equal to 0, so x equal to 3. x squared minus 25 different from 0, so x minus 5 into x plus 5, the factorized form of x squared minus 25 is different from 0. So here we have x minus 5 different from 0, x different from 5, and x plus 5 different from 0, so x is different from minus 5. The second step, we plot the table. Here we have three binomials, x minus 3, x minus 5, and x plus 5. At last we have the quotient. Here minus infinity plus infinity the domain, and the roots in order, minus 5, then 3, then 5. The first binomial x minus 3, it's 0 at x equal to 3, so put 0 at this column. Before the root, opposite sign of a, so we have negative signs since a is 1 positive. After the root, we have the same sign as a, so we have positive signs. X minus 5 is 0 at x equal to 5, so put the 0 at this column. Before the root, we have opposite sign of a is equal to 1, which is positive, so we have negative signs. And after the root, we have the same sign of a, which is positive, so we have a positive sign. X plus 5 is 0 at x equal minus 5. Before the root, we have opposite sign of a is equal to 1, so it's negative. And after the root, we have the same sign as a is equal to 1, the same sign as a, so we have positive sign. At last, we need to find the sign of the quotient, so we multiply all the signs. Minus times minus is plus, times minus gives minus. We have three negative signs, so odd number of negative signs, so we will get a negative sign. Here, the quotient is not defined at x equal minus 5. We say that x does not equal minus 5, so we shade this column. Here, minus times minus is a plus, multiplied by plus gives plus. 0 multiplied by x minus, divided by x minus 5 over x plus 5 to get 0. Plus times minus times plus gives a negative sign. And here x different from 5 as we said before. So we shade this part, and at last three positive signs gives a positive sign. Now, solving inequality of the form a over b less than 0, a over b greater than 0, a over b less than or equal to 0, or a over b greater than or equal to 0. First step, solve if possible a equal to 0 and b different from 0. Second step, set up the table that includes the roots and signs of a and b. And the third step, find the set of values of x that makes the inequality true. Example. Solve in R the inequality x minus 2 over x plus 1 greater than or equal to 0. The first step, x minus 2 equal to 0, so x equal to 2. X plus 1 different from 0, so x is different from minus 1. The second step, we set up the table of signs. X minus infinity plus infinity. The roots minus 1 and 2 minus 1 is less than 2. The first binomial, the second binomial, and the quotient x minus 2 over x plus 1. Here, x minus 2 is 0 at x equal 2. Before the root, they say the opposite sign of a is equal to 1, which is positive. Opposite sign is negative. After the root, the same sign as a, so we have a positive sign. X plus 1 equals to 0 at x equal minus 1. Before the root, opposite sign of a is equal to 1. Opposite sign of a is negative. And after the root, the same sign of a, so we have positive sign. Now, the sign of the quotient, we multiply the signs in the table. Minus multiplied by minus gives plus. Minus 1 not included in the domain. We say that x does not equal minus 1, so we shade this column. Then minus times plus equal minus, and 0 multiplied by x plus 1 is equal to 0, and plus times plus is plus. We need x minus 2 over x plus 1 greater than or equal to 0. So the solution is in this section and this section. Minus 1 is not included since it's not defined at minus 1. We have a shaded region. 2 is included since we need greater than or equal to 0. So the solution is x belongs to minus infinity minus 1 minus 1 is open, not in the domain, it's shaded, and union 2 plus infinity, 2 is included. We have a closed interval at 2 since it's 0 at 2 and we have greater than or equal to 0. Application. Solve in R the inequality x minus 2 over x squared minus 9 less than or equal to 0. Solution. First, x minus 2 equal to 0, so x equal to 2. X squared minus 9, which is equal to x minus 3 into x plus 3, we perform the factorization. It's different from 0, so x minus 3 different from 0, x different from 3, and x plus 3 different from 0, so x is different from minus 3. Now, we set up the table of signs. X minus infinity plus infinity, the roots minus 3, 2, 3 in order, x minus 2, x minus 3, x plus 3, and at last the quotient x minus 2 over x squared minus 9. X minus 2 is 0 at x equal 2. We put 0 at this column. Before the root, opposite sign as a of a. Here a is equal to 1, so opposite sign is negative. After the root, the same sign as a, so it's positive. X minus 3 is 0 at x equal 3. We put 0 at this column. Before the root, we have opposite sign of a. A is equal to 1, the coefficient of x, so a is positive. Opposite sign of a, we have negative signs. And after the root, the same sign as a. X plus 3 is 0 at x equal minus 3. Before the root, opposite sign of a is equal to 1. So opposite sign of a is negative, and after the root, the same sign as a. Now, x minus 2 over x squared minus 9. We perform the multiplication of the signs. Minus times minus times minus gives a negative sign. Minus 3 is not included in the domain. We have x does not equal minus 3, so we shade this column. Then minus times minus is plus, multiplied by plus gives a positive sign. Here, x equal to 2 gives a 0. 0 divided by x minus 3 into x plus 3 gives 0. Plus times minus times plus gives a negative sign. And here, x does not equal 3, so we shade this column 2. And at last, plus times plus gives a positive sign. We have x minus 2 over x squared minus 9 less than or equal to 0. So the solution is in these two sections. So the solution set is x belongs to minus infinity, minus 3. Minus 3 is open. Since it's shaded at minus 3 is not in the domain. And the second part of the solution is 2, 3. 2 is closed since we have less than or equal 0. And 3 is open since it's shaded, not included in the domain. Do the assignment. Focus on the summary. Coming next. See you in the next video. Please stay safe.